All right, enlargements. Okay, so in this video, our learning goals are to define enlargement and dilation, scale factors, and similar. We will enlarge figures with a scale factor and a center of enlargement and understand how a scale factor affects dimensions. Okay, so first off, okay, we know what an enlargement is. We can get bigger, okay? We can get big, we can get small, and let's talk a little bit more now. So what is an enlargement? So when do we use this? Well, if we have a real life horse and we want to make a picture of it, well, we make a scale drawing, and that's actually called an enlargement. So an important thing that we're going to talk about is that even if the shape or figure is getting smaller, it is still called an enlargement. Enlargement. Now, and that's just the mathematical term. In some places, they call this, where we get smaller, we would call that a reduction. But it really is just an enlargement. In the US, an enlargement is called a dilation. It's literally the same thing, okay, but we have a different word. I would say enlargement makes more sense. We can see in there we have large, but a dilation comes from that as well. All right, so let's take a look with some math here. Okay, we are familiar with enlargements in the forms of photographs. Okay, zoom tools and computer software. We can go in, we can go out. Okay, or looking through a microscope. For an enlargement, the image is larger than the original. Now, here's where we're going to differ from this. So we're going to use the term enlargement for everything. We're not going to use this term reductions at all, but it is nice to see it and know that it's not wrong. We're just not going to use it. Everything's going to be an enlargement. So the scale factor of an enlargement is the ratio by which the side lengths of the object are enlarged. Consider this diagram below. Okay, so they're clearly not the same size, but they do have the same shape. Okay, their side lengths are in the same proportions. So it's telling us that, okay, they're the same, not the same size, but the same shape. Well, what do we call shapes that are the same shape but not the same size? These are similar shapes. Same shape, different size. So everything we're doing with enlargements, okay, the same shape, different size. This is different than the other transformations that we've talked about because they haven't changed their size. They've only changed how they've looked. So for like a translation, a rotation, a reflection, okay, they don't change their size. So those shapes are congruent. Same shape, same size. Now, all right, so let's see what has happened with our A, B, and C figures here. B is an enlargement of A. B is an enlargement of A. We took A and we got B. It's a bigger shape. Okay, we could say C is a reduction of C, but it's also still an enlargement. Okay, it's just been enlarged by a fractional scale factor. So how do we figure this out? If we read here, they give us the information. When A is enlarged to B, the side lengths are doubled and the scale factor is 2. So if I take this side right here, I have a side of 2. But if I look at B, I have 1, 2, 3, 4. Okay, our image over our object. So remember, this is our new one over our old one. Okay, so if I take image over object, 4 over 2, I get 2. Okay, if I use this side of 1 and a side of 2, my image side is 2, my object side is 1, gives me 2. Let's try it on the bottom. We have a 2 here and a 4 here. Okay, so if I take 4 divided by 2, I get 2. Okay, so that works for all of those. Alright, so on all of our sides, we have that same proportion, that same ratio, and that's 2. Remember, k is our scale factor variable. We always use k for the scale factor. Okay, what if we wanted to go from C to B? Alright, what if we wanted to go from this big one down to a small one? So we need to enlarge it, but by what? Well, let's use, we know this side is 4. Okay, 1, 2, 3, 4, 5, 6. Okay, so this big side is 6. And we need our image over our object. So in this case, C is our object, because it's our one we haven't changed. And we have our image, the one we are changing it to, okay, has this same corresponding side as 4. Okay, we get 4 over 6, and we can reduce that to 2/3. And so in our example here, 2/3 is our scale factor. Okay, it is enlarged by a fractional scale factor. Okay, so remember, if it's greater than 1, it gets bigger, it expands. And if it's less than 1, okay, it shrinks. Alright, we cannot have a negative scale factor. So, what is the scale factor? Let's figure it out. So remember what we just said, scale factor greater than 1, it expands, gets bigger. And if it scale factor less than 1, it shrinks, gets smaller. Okay. Let's just do this one for now. So I have A and A prime. So what's our scale factor? Let's take, we can see this side, okay, we can deduce that it goes to this side here. So this is 1 and 2. And remember we said it's going to be image over object. Image over object. So A is my image, or sorry, A is my object, A prime is my image. One way you can think about that is image gets this little apostrophe. It kind of looks like an I. Alright. So 2 over 1, image over object, it gives me 2. We could chest that on down here. We have a side of 2, and we have a side of 1, 2, 3, 4. Okay, that also will be 4 over 2, gives us 2. Alright. Try to describe the transformation, okay, from A to B and B to A here. Okay, so in this one I would say A is enlarged with a scale factor of 2. Okay, try these ones, pause it, and then come back. Okay, so for part A to B, so we want to go from A to B, so A is our object. So I'm going to have A object over B image. So I have a side of 2 and a side of 1, 2, 3, 4. Okay, so yet again we're going to get 4 over 2. Okay, it's 2, so this is my K equals 2 there. Okay, what if I wanted to go B to A? Okay, now I need to flip it, because now B is my object and A is my image. So now I need to do, instead of B over A, I need to do A over B. And in this instance, A is 2, okay, B is 4, I get 1/2. So my K equals 1/2 here. Now, you don't necessarily have to use this side. Okay, you could use this curved distance, and it would work exactly the same. However, this curved distance involves finding the area of a semicircle, okay, and using pi and calculating that. I wouldn't recommend that. You could find this distance here, okay, and that would work. That's a 1 and a 2, so 2 over 1, or rather on this example we're doing 1 over 2, and we're already reduced all the way. So you can compare any two corresponding sides. It doesn't make a difference. Okay, so you have to be smart about how you want to do it. Okay, the center of an enlargement. So sometimes we want to enlarge by from a certain point. Okay. So on these last ones we were just enlarging. Well, now we're going to enlarge from a certain point. This is quite simple, not too bad. So it already tells us our triangle PQR has enlarged to triangle P prime, Q prime, R prime using a scale factor of 3. So we already know. We can see this side is 1, so PQ is 1, P prime, Q prime is 1, 2, 3. Okay? Now, they have been enlarged from a point, meaning there's been some point where they were, and they've both gone from that point. Here's how we find this out. We take a straight edge. It doesn't have to be a ruler, but ruler helps. Okay? And you map it over. You make a line from your original, your object, to your image. You make a line there. Okay? And what you're going to need to do is you're actually going to need to extend that line. You keep extending it like that. Okay? Now you're going to need to do that for all 3 points. And we're going to try to figure out where those points connect. So I'm going to use P now. So P to Q, I'll do this in a different color so maybe we can see it a little bit better. So from P prime to P, I'm going to keep it going because I can see it's going to connect over here. Alright, so as long as R prime, well here's R and R prime, as long as these connect, we're going to be good to go. Let's do that in blue. Okay, we connect. Okay, and we even cover up the green. So our center of enlargement, I know it comes off the screen a little bit, but is right there. Okay, it doesn't ask us for the coordinate of it, it just asks us where it is. So our center of enlargement is right there. Let's see it on C. Okay, with C, we'll come back to B. Let's do it with C. So we line up our straight edge. Let's do P first. Okay, line it up. Okay, I'll do the same colors as I did before. Red for P. Okay, you can continue it both ways. Then let's do, I guess I did Q, red for Q on this one, doesn't matter. Okay, let's do R. So line up one, line up the other. Okay, line it up. Cross. And let's do Q. Okay, and our center of enlargement is where they all cross at that point right there. Okay, now with B. Okay, well, let's think about this one. Okay, if I made a line, hey, where's our P prime? There is no P prime. Well, that's because P prime is already here. P and P prime share the same point. If I made a line, and let's do that in maybe a dot. If I made a line from here, Q prime goes through Q and connects down where P's at. If I make the line here, well, they connect there. And so our center of enlargement is actually exactly that point where P was at. Okay, so if you have a point, okay, that was already on your center of enlargement, that point's not going to move. Okay, using a scale factor and a center of enlargement. So find the image of the figures with the center of enlargement O and a scale factor given. So with our blue A, we're going to do a scale factor of 2 with the center of enlargement. Okay, so remember on this one we said if our center of enlargements on our shape, it's not going to move. So all we need to do is make this, take it and use it with a scale factor of 2. So take this shape, okay, from here, where we know this is 1, so we need to go up, well, twice that, 2, and this is 1, 2, so we need to do double that, 1, 2, 3, 4. Okay, and we know we need to make this a rectangle, so we just need to connect it back. There we go. We've successfully connected that and done that with a center enlargement of O, okay, by a scale factor of 2. Okay, with B, we need a scale factor of 3 from this center of enlargement. So our point's not on it. So how we're going to do that then is we are going to, let me take off the arrow function of this actually. Okay. We're going to count the distance. So we are 1 away here, and we have a distance of 1. So this is 1 and 1. I know can't see that. So this is 1 and 1. So our next one needs to be times 3. So this is 1 times 3 and 1 times 3. So our distance needs to be 3 away and a length of 3. So we need to start 1, 2, 3 away, and then make a length of 3. Then this is 2. Okay, and so our new one needs to be 2 times 3 is 6. So 1, 2, 3, 4, 5, 6. Okay, and we could connect our rectangle now. We can see that it's clearly a rectangle. Okay, so we have 2 sides. That's good enough to go. All right. If we check it, we notice this is down 2 over 1. So if we do down 2 over 1, okay, this new one should be down 6 over 3. So is it down 1, 2, 3, 4, 5, 6 over 1, 2, 3. All right, that works. Okay, and our last one, use a scale factor of 1/2, and our center of enlargement's actually inside of our shape. Okay, well, we're just going to count. All right, so I need to go by 1/2. So I need to take all these points and I need to bring them 1/2 closer. Well, let's start here. This is 1, 2 away. Well, if this distance here is 2, 2 times 1/2 is 1. So I have a point there of 1. Then this distance here is 1, 2, 3. Okay, so I'm going to go exactly halfway in between. And I can do that the rest on those main points of the star. Let's make these red so we can see. Okay, but now we have these points here. Okay, they're not so easy to count. Okay, they're not directly on the grid. Well, here's how we're going to do it. This is 1, 2, 3 over, and 1, 2 up. So it's 3 over, 2 up. We're just going to multiply those both by 1/2. So 3 times 1/2 is 3/2, or 1.5. And 2 times 1/2 is 1. So I need to go 1.5 over, 1.5 over, and 1/2 up. Okay, and I can use that same logic to figure out the rest of my points here. So to get this one, it's also going to be the same. So 1.5 over and 1/2 down. This one is going to be the same. 1.5 over and 1/2 up. And our last one here, 1.5 over and 1/2 down. Okay, so we've plotted 1, 2, 3, 4, 5, 6, 7, 8 points, and we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Okay, we have this point here. So we know these are going to connect. But we know if we connected this, that would not create this star. So this distance here is 1 over and 2 down. So 1 over, 2 down. So 1 over times 1/2 is 1/2 over from our center, and times 1/2 is going to be 1 up or down. So 1/2 over and 1 down, 1/2 over, 1 down, 1/2 over, 1 up, 1/2 over, 1 up. We could connect our points. And this is where I realized that all these points we did here using this 3 over and 2 up, okay, well, we marked them at the wrong spot. We said they should be 1 over, but we only put them 1/2. So they should be here. So let's go through and fix that. Okay, so if we connect our lines, boom, 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 boom. Okay, now we've created this strange star, and it is exactly, if we made perfectly straight lines, it is exactly, okay, shrunken by the scale factor of 1/2. It is 1/2 smaller. Okay. All right.